Welcome. In this course, we are looking at the System Security Certified Practitioner, also known as SSCP. This lecture is based off of the book System Security Certified Practitioner, the Official Study Guide, 2nd edition. ISBN 978-111-9542940. A lot of the graphics and content in these video lectures are all taken out of this book. I'm assuming that you have this book. These video lectures are just to kind of reinforce concepts discussed within this book. Lesson 9 is about application, data, and cloud security. We have 3 main objectives. We're still working in Domain 7, the System and Application Security domain, but in this lesson we're looking at implementing and operating endpoint device security, operating and configure cloud-based security, and operating and securing virtual environments. So first of all, what's the purpose? At one end of the problem, we have vendors-provided resources such as application, data, services, and on the other end, we have user-created applications. And this could be simple formulas in a spreadsheet, macros, web content, things of that nature. The issue is there's a risk of what incorrect data or altered data can do. We can also misuse that data inappropriately. So when we're looking at this, we have to understand that that data, that information is what is needing to be protected, both from the vendor perspective and from the end user perspective. A good example that I often share with learners when I'm doing this is, let's say you work for a sales company. You're selling, you're dealing with customers that do truck rentals, or you're selling truck information. Well, your company really owns those clients. You don't. You may have the relationship with them, but it's all information that is actually owned and governed by your organization. However, if you leave that company, you shouldn't be allowed to take that data with you because it's technically owned by the organization. However, oftentimes that relationship is just as valuable as the data. So as the individual leaves, even with not leaving with the data, the customer, your organization, might actually be losing those customers, those potential customers, former customers at that point. So big part of this is understanding that when we're looking at the problem, it can come in multiple avenues. So the perspective is it's all about the actions that are happening. And when we're dealing with this lesson, we're focusing on the endpoint. How do you ensure that the sales rep is not siphoning off customer data, for example? Well, we're going to be looking at that from the endpoint secure perspective. One thing to take note of is it really is about data-driven decision making. The issue is at the endpoint, that is where the data is being collected, analyzed, and that's driving the decisions. So data, before it turns into information, can be manipulated, processed, combined. It can create information. Information is just data with context. But the interesting part is, here we're looking at how the data can be modified into a pyramid, and that's going to be the data, information, and the knowledge pyramid. I like how they always bring in wisdom, but realistically there the knowledge is funneling the data and information into something more meaningful, knowledge, not necessarily wisdom. Another thing to point out is at the endpoint there are boundaries. The boundaries are what allow us to translate the business logic, the security and the goals and the mission of the organization, the software, the data, all of the mechanisms inside the organization that help us help the organization overall to run. Those set up the boundary. That sets up how we can work within that organization while dealing with the data and the endpoint connectivity to that data. There's also outside of that boundary, and that's going to be more of the physical administrative type controls. For example, by the nature part of the real world, the physical world, there are controls, there are sensors, there's control technologies that might be used throughout the information security systems. While they're still part of the organization, that's going to be more focused on outside of the endpoint connection. So the boundary itself represents the threat surface. Meaning if we're looking at a server, if we're looking at a system or a phone or a tablet, those will actually have threat surfaces. And the threat surface is basically a logical construct which is subject to the attempt to cross into one world to another world. And that's going to be, if we're dealing with a tablet or a computer, the ability for outside access to access the information or data. Our book talks about taking our physical data into a virtual environment. Well, that also is part of it, but that's not all of it. Keep in mind that data-driven logic will help separate the systems that we should be protecting versus the systems that we don't need to protect as much. Again, part of this is we have to be looking at an assessment plan or an assessment of the endpoint so that we know where crucial or what critical data is on or being accessed by those endpoints so we can supply the appropriate protection. If we have a kiosk in the waiting room versus a server, we're not going to spend as much time protecting the kiosk if it doesn't have access to crucial or critical data. We only have so much of a budget, so we have to actually pick and choose where we're going to focus our resources. One interesting thing to point is at our endpoints, it's not always data that is handled at the endpoint. It could be data accessed by the endpoint. So the first section of our lesson actually talked about how data-driven endpoint security is specifically dealing with application software, apps, or appliances. And that is going to be what applications that will be accessing data by the endpoint and how those apps and appliances are built and secured as well. That's also going to be counted towards the endpoint. So one thing that we have to discuss is layers. What happens when there are inside and outside boundary layers? How do those intersect and what happens at those intersections? And again, when we're dealing with that is we are talking about being able to protect the intersections. So when we're dealing with an outside and an inside type layer, that is where we're probably going to implement the most stricter controls. Every boundary layer has X amount of layers deep. So it's not going to be a single boundary layer. It's actually going to be several boundary layers deep depending on what we're trying to protect. If we're dealing with application, we may have software called middleware, and this is used to broker information. This could also be the interface and the application of the software. It could be the front end of a web portal, could be the front end of a database. That's all going to be the middleware. The larger functions of middleware actually are very feature-rich platforms. You go to Amazon, you go to Google. That middleware, that broker section, that interface is going to be feature-rich depending on what they're trying to accomplish. It could also be as simple as like a entity relationship platform or ERP type platform. All of this is going to provide additional features as the interface between us, the users, and the end device for accessing data applications may grow. One important section is the separation of the app and the data from the infrastructure. The infrastructure is going to be the communication medium, the actual exchanging of data between client and server, or between client and web requests, assuming it's a web portal. Even then, that'll be that type of server. The app and the data are separate from the data that's on the network. While data may transpire or may actually go over the network, it's separate from the data that's in the network itself. So there are a few important truths that this chapter pointed out. That one of them is that with many of the issues that we're dealing with, like access control, data protection, as it pertains to the app and the data, it will view the physical world, the real world, also. If we're looking at application security or app protection, while that may all be intangible software, we still have to work with how do we secure the endpoint that software is installed. So there are issues of like access control, physical controls there. Another important truth is that endpoint security can make or break everything else that we manage within our informational risk and our decision risk making. Meaning, our endpoints are where our end users are consuming or generating that data and information. If our endpoints are poor, then our connectivity to anything else is going to be just as poor. Garbage in is garbage out. If the endpoints are not protected, that probably means the majority of things are not protected. Also, if our endpoints are not protected, then our end users that are using those endpoints are susceptible to being compromised. Phishing attempts, malware, or some type of social engineering could take place on those workstations, those endpoints, that could compromise them. The third important truth for this lesson is that cost-effective allocation of our management and our mitigation techniques might decide what particular risk is appropriate. One of the things is not all risk will be mitigated. Some risk will be accepted. Some risk will be tolerated. Some risk will have to be mitigated, but it all depends on the cost effectiveness of protecting that risk and likelihood of occurrence. For example, I may protect a endpoint by locking it to the desk, physically securing it. Well, the lock may cost $10. That works. However, I could go the next step further. I may install, a cage around the device and cameras that monitor it 24/7. Well, at that point, the cost of protecting the endpoint is so expensive that it's no longer worth actually protecting, because the cost of replacement of that device is actually cheaper than the cost of protecting it. You also have to look at what data is on the device as well. It's not always about the physical device, but the point of that is it's a balance between management and mitigation of risk. The fourth truth is that endpoints that actually allow data to be used as information, that process actually has value. That process normally generates functionality or work. That work can turn that data into information, and that information is what's of value. So keep in mind that sometimes the systems that generate the content is what's producing that perceived value. The last important truth that was brought up in this lesson is that it's not always about information security. It's about assessing and assuring the ongoing operation of the business. specifically at the endpoint by means of the appropriate controls. Several years ago, there was several data breaches at Sony. Well, what was interesting is Sony had to replace a lot of their endpoints. Well, it wasn't as simple as going out and buying a bunch of endpoints. They actually had to go out, purchase everything, they had to prepare everything, and then distribute everything. It took them months. They had to pay staff to sit there idle while they were waiting for their end devices to come back. So again, it's not always about protection. It's not always about security. Sometimes it's about how do we recover? How do we ensure that we can quickly recover? And again, part of that is understanding the terms of how do we recover the software, the data, the procedures, the business processes, the business logic, if appropriate. What is interesting is software as an appliance. That means that general computers are used as general purpose. Your cell phone is a general purpose, a tablet's general purpose. While you can have smart devices, these are often defined as special purposes. Special purpose devices are going to perform very specific tasks. Yes, you may be able to browse Facebook from your refrigerator, but it's not as easy to install an application that might do more complex computations. That ability to install software is what denotes general purpose as opposed to special purpose. Special purpose could also be things like for small offices, home offices. Could be dedicated pieces of technology for like a POS or a network storage device. Those are going to be special purpose devices. While all of them still need a specific level of endpoint protection. Your smart refrigerator, your smart washer dryer, your smart coffee maker, your smart thermostat, all of those need a certain level of protection. Even though they're not general purpose devices, they still have their own specific needs. So that means we have to understand those special devices. Those special devices typically are also called IoT, Internet of Things. And those are going to be devices such as like a smart thermostat or smart sensors. All of this deals with endpoint functionality. And that means the functionality is being packaged and deployed as appliances. That's going to be, again, instead of this traditional feature-rich, they could have more limited features. Your smart refrigerator may only have very specific things that it can do. So IoT versus appliances. IoT is a little bit more robust. A smart thermostat often will be called an IoT device. However, more often than not, it's a smart appliance. It's not always an IoT device. Some of them are just smart appliances. Part of that is how easy it is to get them to perform functions. How easy is it for them to take, package, and deploy data, collect data, send data. That's what helps separate IoT versus appliances. So that actually is one of the more complex concepts for people in this lesson. So for example, an appliance, smart thermostat, where an IoT device might be an orchard, the orchard's ability to use a Wi-Fi enabled GPS savvy sensor and control system that allows us to use like GPS data and other GIS information to actually control a drone to irrigate the appropriate orchards. That would be IoT. It's multiple appliances, multiple devices being able to generate data for a purpose and then to be able to communicate with one another so that a given task is complete. Keep in mind the boundary lines between IoT and appliances are becoming very blurry. They are definitely blurring, because at what point do we say the devices should not be communicating with one another? One could also make the argument a smart refrigerator that allows the end user to remotely log into their fridge camera to see what they have could also be an IoT-based device, as it has moved away from appliances. So how does any of this relate to endpoint protection? Well, endpoints deal with applications, the apps and appliances that access that data. So we need to have a way to secure those apps. Our book actually brings up 5 questions to ask. How do we identify and resolve vulnerabilities in this app that we are writing? How do we formalize process for all the apps across the life cycle? How do we dispose or retire of user data? How do we handle apps that end users develop? How do we configure management and control of applications permissions? Do we work to continually improve and mature those softwares, or do we let those life cycles go away? At the end of the day, any of these questions that have a negative or incomplete or unclear response highlight the potential risk that is involved with those apps. Any application that has code, that deals with users, that deal with infrastructure, that deal with any type of communication, all should have a plan for updating, upkeeping, how to retire, how to dispose, how to verify that end user data has been removed. I actually was recently working with an app developer that was new to understanding that they have responsibilities for end user protection. The end users, the consumers, had an expected right to privacy when dealing with certain user data, and the app developer had zero clue about it. So there is a life cycle for this software development. The life cycle is called the Software Development Life Cycle, SDLC. There are 6 main stages: system analysis, system design, development and test, accept and test, deploy to end users, end of useful life. So keep in mind, with this process, this is called a waterfall process. Start with the very highest task, and then it drops down to each lower preceding task. Each area has a very specific criteria that it's doing. So system analysis, you'll identify function and non-functioning requirements. You'll identify performance requirement that's needed. Within the system design, we're talking about decomposing the total system into subsystems or submodules. We're doing the appropriate resourcing, and we're designing those submodules or modules. Test and development, we're looking at coding and testing the modules, integrating into a much larger system, and then we're testing for completeness. 4th step, we are looking to ensure that we have met the requirements that we were identified and that we were scoped to do in the system analysis area. We're also then double checking to ensure all non-functional needs, if they are being met or not. Then we're going to talk about user training, user updates, process or module refinement, maybe maintenance and support. We may have to also then go back to a previous stage and correct anything that end users report. And after enough updating and enough of that process, we may get to the point where we retire or end it. And that means we can either rebuild the app, start over, update it. We could then or replace it. We could look at retiring this application and then actually going with a new application, maybe developing from scratch or taking components or modules from this and then taking those sections to the new application. So part of SDLC, again, it uses the waterfall method. This allows for clean decision points in each of the sections. These mild points are called milestones. And we can actually say we're going to do this, and this is how we're measuring it. This is the metric that we're using to measure our completeness of this portion. And you break up any project into manageable chunks with measurable outcomes, and those outcomes again are those milestones. That way we can ensure that we're able to complete the project appropriately. Part of this process of breaking it down into milestones allows us to keep the project on schedule and within cost. While often this is difficult, when a project is actually broken down into more manageable chunks and the correct metrics are there, it's a little easier to keep the project moving forward. One of the problems that is often brought up when we're talking about software are well-defined requirements, also scope creep. Requirements are going to be what is required by the software. Scope creep are those additional little features that might make this a little bit better. Not required, but would make this app be a little bit better. So it's natural to have some scope creep, but again, the important part while dealing with a project is the ability to end the project. We can always update, upgrade later once the project has come to a conclusion. So when we're dealing with software, we have these IDEs, Integrated Development Environments. This allows us to be able to build our coding repositories or provide a platform for us to code on top of. Because we're dealing with security, we may run into a number of different strategies for software development. Things like Agile, Scrum, Rapid, Prototyping, Code First Design, and so forth. It's important to understand not to lose sight of the purpose of what we're trying to accomplish, and that is protection of the data, the application, by the end user and end device. Again, oftentimes we are security professionals, not coders. So we're not expected to understand everything about coding, but we need to understand that during the coding process, we have to ensure that a certain level of security is in place. That brings us to a very important question. Why is software so insecure? Our book actually discusses poor design, inconsistent use of patterns, poor coding practices, poor coding best practice utilization, inconsistent use of the appropriate and proven test design, or it could just be that programmers don't have a good outlook on security. Again, not all programmers, this is just a general statement. I've dealt with a database individual who built a database reservation system who truly believed that security was pointless. He built reservation systems for high-end travel agency companies to use. This allowed people to log into their web portal and schedule and book reservations. The problem is the back end was so insecure that it had been leaking credit card data for years. The developer did not care. He was a database person. So security was not his problem. We had to educate the individual about expected rights to privacy. Like when a user uses our application, our users are expecting us to provide a certain level of protection, especially as they enter PII and or credit card information. Not only honestly, we weren't, because after we reported this, we recused ourselves from that company because the company no longer wanted to keep secure. But the important part is sometimes you have to make that line in the sand, tell the programmer or the developer that this is a certain level of protection that must be there. And if it is not there, then you cannot function. And at a certain point, you have to walk away. Moving on, things like management software design. Well, we have things like data types. You have a user field where someone types in a... So, for example, we were talking about being able to enforce data types. So if we have a field for, let's say, quantity, we should only allow numbers. We should disallow letters. If we have an area for an email address, we can do enforcement of a string character. So something at something dot something. We can have it so that the appropriate data modeling is there. So that's the next portion is data modeling. Data modeling is a formal process that will translate the business logic into named data elements. If we have a business process for doing web-based applications, first name, last name, email address, they would name the appropriate data elements appropriately. Data typing, that will involve the rules by which the programmer can write code that works on that data item, how we're going to be able to manipulate them. And then lastly is that data quality efforts, and that's going to be the inconsistent or no data quality efforts during operational use. So we have to think about what should happen when a clerk enters a name, for example. If the clerk is entering the name of a long-time customer, then it should be able to bring it up. If the clerk misspells the name, how does that translate? Instead of being able to look up by name, maybe you'll have them look it up by number and so forth. So those types of controls can be there for user input validation. One of the last things in this section that was brought up was hard to design it right, but it's easier to fix. So when we're talking software development, it's always in a constant exercise in a balance of trade-off. It's about being able to build the requirements that's required, but not go too much above. It's about being able to test and validate everything that is built, that ensuring they meet the appropriate requirements. It's also about being able to do it for the price that was estimated. Also about being able to get it done and in the marketplace based off of a time requirement. With any project, management is always constantly trading off between risk versus resource versus time. When an organization has proper defined processes, the ability to do a software project, for example, they should be able to estimate the scope and the time requirements pretty accurately. That comes with experience. While not all organizations have it, this is one area that experienced organizations should already have nice and developed. Moving on are things like application requirements. So any program, large or small, it doesn't really matter, should do what the customer wants it to do. If you're developing it for someone, you should develop to do it what it's being supposed to do, and only do what it's supposed to do, not something else. Good definition of malware is software that contains such unacknowledged or undisclosed features at the very end. So, I've actually encountered this several times where when you have non-coding, non-technical individuals that pay a developer to develop web content or develop an application, and then they sneak in their own content to call out to their resources. Well, technically, that's not what they're supposed to do. A developer should only do the code that is required for the site to function, to meet the requirements, nothing else. Otherwise, it should be classified as malware. So we have this Sienna. This Sienna is confidentiality, integrity, authorization, non-repudiation, and authentication. You'll see this throughout almost the entire book. And this is a concept that has to be in our security, whether it be software and secure coding, whether it be in networking and communication. This is actually throughout everything. So I brought that up here because I wanted to talk about functional versus non-functional requirements. In system analysis, a functional requirement is one that specifies the task that must be completed. The requirement may also specify how it can be verified. For example, the requirement might state that pressing the start engine button causes the prerequisite safety conditions to be checked. For example, by contrast, a non-functional requirement states a general character that applies to the system or subsystems or modules as a whole, but is not obviously present in any particular feature or function. Security requirements are typically defined as non-functional. It's a feature that should be there, not having to specifically state it. For example, when you're building a POS system, you assume that security of the card reading mechanism is going to be there. That would be a non-functional requirement. You do not need to clearly state that it has to be there. It's the assumption that that is already there. So we have two modes for models for software security: whitelist and blacklist. Blacklisting it is a inherent block. Whitelisted is more trust-centric. So blacklisted, it's more threat-centric. It's typically defined as a negative control. Whitelisting is a positive control. More often than not, organizations used to blacklist applications, blacklist sites. And what would happen is you could only run you could run anything that wasn't on the blacklist. So I mean, you could blacklist certain applications once they were known. However, in more recent years, a different approach has been there: whitelisting. So instead of blocking specific things and essentially having to block everything that you want not to be ran, whitelisting basically says block everything except what is allowed. And so you can allow certain applications to run. Maybe you have a computer workstation for an accountant. You allow him Outlook, Word, PowerPoint, Excel, and QuickBooks. If he doesn't need access to anything else, you don't let him access anything else. Maybe the calculator. But I mean, whitelisting is the ability to look at applications and only allow the applications that are allowed. You can do this profile based as well. You can say you can use all Windows features and these additional applications. When it comes to any type of software, person, object, there are vulnerabilities. Our book, this chapter, focuses on application or app development. So the application vulnerabilities will apply to the same old wisdom of any type of written software, and that is there are some right ways to produce code and there are some wrong ways. Right ways are developing and maintaining the software in a more reliable and repeatable way. The wrong way is essentially you can get lucky and you can code something and it can work. However, that's not how you're supposed to do it. There's a structure and approved method for writing code that you should be following. And doing it by accident doesn't mean that you can repeat it. So that's what makes it wrong. There is a vulnerability across the life cycles. So essentially, when we're looking at the application, we're looking at software development lifecycle, we have several main threat vectors. We could be looking at the operating systems, the infrastructure, the software. All of those can be exploitable. If we're looking at the IDE, the environment, the tools, again, all of those could be exploitable. The ideas, the code, the documentation can also be vulnerable and exploitable. The process of taking really good notes while programming in the right context could also be vulnerable. Keep in mind that the development environment are successful and susceptible to attacks, meaning attacks can easily affect them. Attacks can be successful by attacking them. So insecure environments, whether it be a physical, local, whether it be network or cloud-based systems, are out there. They're easy to break into. And once they're broken into, things like hostile code can easily be injected or fragmented. And oftentimes, larger applications with more lines of code, you can have attackers inject lines of code in key areas that you may not even realize, or the developer may not even realize. That compromises the entire system. Human failures and frailties. We are people. Whether we're a networking person, a security person, a programmer, we need to understand that we are people. We are susceptible to things like phishing attacks, social engineering, con artists. These crimes typically allow one person to cause or commit a scam against another. These are called confidence artists. We're people, it happens, but we need to ensure that we have controls built into place to ensure that our nature, our human failures, are not able to be taken advantage of as easily through the software development portion, life cycle portion. So what happens when the user is the developer? We end up with things called shadow IT. And shadow normally refers to things underneath the radar. Shadow IT, however, is any process, business logic, procedure, software, data, any type of element that are used outside of the normal process that the organization uses to manage that development, use, support, secure its infrastructure, data, and applications. The interesting part here is it could be as simple as a macro in a spreadsheet. It could be anything that executes code on a user's system. These are things that may help the end user, but can also be exploited. So data and metadata as procedural knowledge. So when we look at data, whether it be data, metadata, information, it's procedural in nature. It means there's information that tells the organization what to do and kind of how to do it. It's procedural. So the ability to proceed as administrative, human-facing information products, they need to provide a step-by-step instruction, a SOP, standard operating procedures. Those constraints, those exceptions, those all are built into how to do things, handling the rules, how the organization processes things. It's important that you understand that data as value, it has fields, it can describe, it can be modeled, it can represent aspects of the entity, the organization, where metadata by itself is just data that describes, limits, or establishes the constraints about the data itself. Metadata is, again, information or data about data. The entire purpose of this chapter is so that the SSCP certified practitioner can help reduce risk as it relates to end user, end device, in applications and appliances. One of the key ways this can also take place is by having that practitioner engage in the appropriate assessments and impact analysis. That includes vulnerability assessments, risk assessments, and so forth. These allow for direction, for guidance, so that management or leadership can set those priorities. The priorities of running the organization, the business impact allows information to be used to better prioritize. So information comes in two main flavors, quality and assurance. Normally, No one just gathers information just for the sake of it. There's a reason. Information helps make decision making better. If you know System X runs the business, System Y is a nice thing to have. If the business is down and X and Y are both down, what do you bring up first? Well, the impact analysis should outline which system is the most crucial. That is what is then brought online. Remember, when you're doing the analysis, when you're doing the impact analysis, when you're doing the assessments, vulnerabilities or risk assessment, whether you're doing developing in code or doing testing and verification of code, the concept of garbage in, garbage out is always there. Bad information will lead to waste, lost time, wasted effort, and lost opportunity. The sad fact is, you get in what you put out. You put out what you get in. Garbage in is garbage out. Trying to take shortcuts only means you're probably going to spend more time in the long run trying to do this process correctly. So information quality has a life cycle. So is there, when we're dealing with app development or users as the developers, we have to understand if there's a formal information quality program. How are we ensuring the code is done based off of best practices? Are we doing this based off of videos off of YouTube, or do we have a programmer with the appropriate experience? Do we have and use formal data dictionaries or a data model? Is it documented? Is there any type of data model under formal configuration management or a change control? Again, where is this documented? Where is the change control governed or documented? What's the process? How do we define the process? How do we find the process? Do we know how and when bad data impacts the process? Have we tested the organization, the application, the systems to ensure if we receive bad data that we get an appropriate response? Again, garbage in is garbage out. If we allow garbage data to be put in, we should have some type of control that filters it out. Lastly, how do we recognize it? How do we recognize bad data in, bad data out? How do we recognize good data in or good data out? What are our baselines? What are our benchmarks to ensure our understanding of quality information? At the end of all of this, it's about being able to protect data for the end device. So, first of all, you have to understand data protection requirements. Data has three main states: data in motion, data in use, data at rest. And that means we have to develop protection mechanisms at each stage. Data in motion is going to be data as it flows through a network. Data in use is just that. It's data that's being used. Data at rest could be long-term storage that's just sitting on a drive that's idle. It doesn't matter where the data is, the data needs to be protected. There are expected rights and privacy requirements about data depending on the type of data and the country. So data exfiltration first, the traditional threat. So most computer crime statutes define theft as the unauthorized removal or copying of data from someone's system. Although that legally defines the crime, the IT security industry has been calling this data exfiltration. Recent years, there are 5 main stages. There could be a 6th stage that is basically covering your tracks. However, the common exfiltration attack covers 5 main stages: reconnaissance, initial compromise, establish CNC, identify, select, acquire, and aggregate the appropriate data, remove or extract that data. These stages are typically called the kill chain. The important part here is, if you know the stages, if you understand what's going to occur at each of these stages, and you start recognizing this type of function on your network. Let's say you see data in motion, and you see there are certain types of data in motion that are more scanning based packets. They're doing an ARP scan, for example. Well, you can start spotting, oh, maybe that's stage one. As you're able to start spotting the different stages, you can now implement the appropriate controls to prevent the data exfiltration. Part of that is being able to detect the unauthorized data acquisition. First, you have to have a more security conscious environment. Are there firewalls? Are there IDSs? Are there IPSs? Is there appliances there that is specifically looking for hardware or software or data to tag correctly? Is there a security event information management SIM and analysis capability? If we keep seeing someone go after a specific system, are we getting alerts? Are we getting some type of message so that the security or the network person can know that we should be looking at this? Keep in mind that oftentimes every bit of information or every bit of data should be protected. Data to one individual could be information for another. You should have the mindset of Big Brother, meaning everything should be monitored, meaning everything should have protection. Everything should be layered in protection. There should be defense in depth, meaning there is not just we have this one password protected file. We have the object password protected. We have things logging and monitoring it. We have logs to verify who accesses it. And we have logs that verify the logs. All of this helps prevent data loss. What's really interesting is in the chapter, we look at things like digital rights management, we look at encryption, we look at implementing digital watermarking. So why is this important? Well, data actually is big money. So when we're able to protect our data, it actually ends up saving lots of money. It can also cost lots of money too if data is leaked out. Office 365, G Suites, a lot of our SaaS platforms actually have tools that are built in to help prevent data leakage. Email encryption, it's already there. Some type of rights management, it's already there. Is it configured? Is it set up? Has it been verified? Has it been tested? Those are the questions that really need to be asked. At the end of the day, G Suite and Office 365 have several layers of protection built in. But does the person administering those tools know how to use them? Do they have the appropriate governing and compliance background to understand what they're supposed to be protecting? And oftentimes the answer is no. Into the cloud. So let's look at endpoint apps, data, and other security consideration. What separates a data center from cloud? Basically virtualization. I understand that a data center can have virtualized servers, and that's becoming more and more common practice. But when we talk cloud, typically a cloud is an environment that is heavily virtualized. The organization, however, is still responsible for the security of their appliances and infrastructure in that cloud. So, common question I get are, what are the common types of clouds out there? Private, public, and a hybrid. Private cloud could be one organization that manages the entire cloud. Public is you can actually rent out or lease out your cloud capability from another organization. Amazon AWS, Microsoft Azure, those are typically public clouds. While we can have competitors use the same public cloud, there are rights and permissions that prevent data from going from one subsection of the public cloud to another subsection of the public cloud. And a hybrid is a combination of both. There's also community clouds and other types of clouds, but these are the big three. What's interesting is the user, the organization, is still responsible for data security. Just because you have your data in Office 365's SharePoint, well, you're still responsible for ensuring that data is protected and secured. Microsoft will do it as well. However, it's no guarantee that they're going to have the same capability. Cloud services model. There are 4 common types of cloud services: infrastructure as a service, software as a service, platform as a service, ID management as a service. These are the different software platforms or service platforms that are cloud tech, essentially. Infrastructure as a service provides infrastructure, CPU, storage, networking, server capability, database management, things like this on the fly. Software as a service is going to be application-based software. Office 365 with having a web-based word processor, or G Suites with a word processor. Those are software as a service. If you're looking for different platforms, for example, platform as a service is going to be there. That's going to provide large-scale, feature-rich application platforms, operating systems, as a service. And lastly is the identity as a service. And this is where we can actually do our authentication and authorization, our availability on the cloud using things like Microsoft Azure, for example. You can have them authenticate to a web-based resource. So what keeps cloud services up and running? This continuity and the resilience. These are 2 main aspects of availability. Continuity measures the degree of which a system can produce, correct, in a timely manner. When input errors or missing data is there, how quickly can it come back up? Cloud-based systems might slow down dispatching while new instances of VMs are out there facing the public. However, overall, this continuity actually allows for long-term longevity, and it does allow for recoverability. Resilience measures the ability of the system to deal with unanticipated errors or conditions without crashing. When you're expecting Y but you get Z, that's unexpected. How do you recover? That's resilience. These cloud services actually provide both continuity and resilience, as well as scalability and growth. So what are some basic threat modelings when we're dealing with cloud? First of all, we have to understand threat surface. The threat surface is going to be what attackers are trying to target. It's what's actually publicly accessible. These allow us to build the boundaries of our cloud services. What is available to the public-facing portion of it? If it's an app, what's accessible through the app? What's accessible that data connections between the app and the backend server? Has anyone verified? Has anyone checked? Lastly, one of the big ones for threat modeling is looking at the contractual binding terms of service, TOS, or things like the service level agreement between the organization and its cloud providers. If you're doing SaaS and you're doing Office 365, what are the available uptimes? What are you not allowed to put in their storage platform? Are there specific things you're not allowed to do? Well, part of this is you have to understand terms of services for your provider and what they expect. Also, what are your expectations? And if they're not part of the terms of service, no, it doesn't exist. So, data exfiltration, when we move to cloud services, issues only increase. The problem is, once you're in the cloud, attackers can come from all different ways. If you're using G Suites, for example, the attackers could attack the platform or the attackers can attack your access to the platform. We've already seen in the last several years attackers that have breached a website because it was publicly facing, but appropriate security controls were not there. Jennifer Lawrence is a perfect example with her nudes being leaked. They broke into iCloud by them not having the appropriate controls in place. While that's been fixed, that's just one of the examples that are out there. Simply put, organizations have to understand that they need to see everything about the IT side of their business and understand that when they move to the cloud, this is only going to drastically increase when they move to a cloud-based system. 1. 2. The number of break-ins are only going to increase because guess what? Cloud-based systems are probably under much heavier attack than on-premise systems. One of the last major sections of our chapter was about legal and regulatory issues. First of all, understand that there are expected right to privacy and there are other expected rights for consumers depending on what state you live in and what the consumers are. If you're a European citizen, there's the expected right to understand GDPR. You're dealing with California, you have the California Privacy and Protection Act. You have very specific compliance requirements that have to be there. So you need to understand data in motion, how it crosses borders, how it crosses jurisdictions, data at rest, the ability for authorities to search it, copy it, seize it, censor it, and so forth. Lastly, data in use. Which jurisdiction is objectionable while others are not. Understand that data in certain countries might actually have to pertain to their cultural standards. If we're dealing with border crossing data, if you have an Office 365 account using SharePoint, and that data happens to be in another country at a Microsoft data center, what laws are governing that data? That's the legal and regulatory issues that are being faced. Legal and other regulatory requirements dictate how individuals can discover, organize, pertain access to, and actually respond to things such as like a data breach. The legal question basically is, consider what happens when you move to the cloud where physical the data is. If there is a issue, what borders does that data may cross? If you have SharePoint and you have a customer upload an inappropriate photo of a minor, well, that could be crossing state lines. That could lead into adult distribution of underage minors. It can spin out of control real quick depending on the content, the data that was allowed on the system, and what happens. At the end of the day, we're looking at protecting the end device. We're looking at countermeasures to keep the data, the applications, the appliances, the information that the end device and end user will be using. We need to keep it safe and secure. So that means we need to understand our responsibilities as data users, data custodians, organizational data users. We need to understand what our tolerance for risk is. How much of a risk are we willing to take on what type of data? Has there been a classification of what types of data we're willing to work with or not work with? Have we classified what our potential customer base or user base may be and the impact or compliance requirements of that user base? We need to establish and prioritize the correct responses to things like our assessment questions, risk assessment, vulnerability assessments, our impact analysis. Do we understand what our business logic is, our business structure? Do we have any contracts? Our TORs, our terms of services, our service level agreements, our other agreements. What are our contract obligations? What are our legal obligations? What are our expected agreements? What is the overall business process, the business logic protection requirements? There's a lot that goes into app and data protection. It's not just as simple as one area. And as a security professional, the sad fact is you're going to have to know a lot more about areas that aren't inside your wheelhouse. You're not expected to be a programmer. However, you do need to understand the process that they go through to ensure their code, to ensure their application is secure. Thank you. If you have any questions or concerns about anything throughout this lecture, please reach out to me. Again, part of this only really works if we have some form of back and forth. Remember, the goal here is data retention, and we do that by talking about what we've read, what we've discussed through our live lectures, and things like that. So do not hesitate to reach out if you have questions or concerns. Thank you, and I look forward to working with you throughout the rest of this video series.